Hi there. Recall that in the previous video, we learned about the four forms of parabola. Namely, these are the general or standard form, the focus or directrix form, the vertex form, and lastly, the intercept form. In this video, we'll be focusing on the general and vertex form. Moreover, we'll learn how to convert this general form of parabola into its vertex form. Our strategy: completing the square. So before we try out some examples, let's try to give a brief explanation on how completing the square works. So we'll have this. So if we are given a squared plus 2ab plus c, so technically c here is just constant, and we'll apply completing the square on is this one out. So our goal is to make this expression of the form a plus b squared plus d. So how do we do that? Well, we'll focus on this two terms out here, or the terms with involving the variable of the squared term. In this case, the squared term is a. So we focus on this as well as this since it contains a. So we focus on this whole as well. So we'll group this one together. Oops, take note that d out here is also a constant, and so we group this one. And now let's apply completing the square. So we focus on this term out here. What we do is we divide this by 2, and we divide this by the square root of the first term, or the squared term, which is a squared. So its square root would be a. Divide these two, and we'll obtain b. Take its square, and this is what we add back in this group. So essentially what we'll do is we'll have a squared plus 2ab plus b squared out here plus c. But since we add b squared out here, to preserve the value of the original expression, we must subtract b squared outside out here. So that when we simplify this would just be equal to 0, which is the same as this one. And now take note that this expression out here is actually equal already to this one, since take note that a squared plus 2ab plus b squared by perfect square trinomial factors into this one. So technically we just take the square root of the first term and the last term and copy this sign out here to get this and put the square out here. So we applied perfect square trinomial out there. Then take note that c minus b squared out here can be expressed as a single constant, say d, since these two are just constants out here. So this one now matches this part out here. And so we know that this expression below is equal to a plus b squared plus d. And so that is how we apply completing the square, specifically in converting a standard form to its vertex form of parabola. So it might be hard to understand how this works, since in this representation we are just using letters to explain the flow of the completing the square in this one. But I hope that in the examples later, you'll have a better understanding on how it works. So without further ado, let's start out with our first example. We are given y equals x squared minus 2x minus 8. Before I solve this one, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's try this one out. So similar to our representation a while ago, we focus on the term with the squared which is squared. So in this case, x. So we focus on this 2. So we'll group this one. So grouping this, we'll have x squared minus 2x plus a blank space out here minus 8. So technically, this is what this 2 terms is what we'll be applying the completing the square on. So what we do, again, focus on this middle term. We divide this by 2 times the square root of the first term, which is x. So these 2 just divides and we'll be left with 1. Take its square, and this is what we add up here. Oops. I think there. Sorry about that. I think technical difficulties. So this is what we add up here. And now out here, again, since we add 1 out here to retain the value of the original expression, we must subtract 1 outside, so that these 2, when combined, is just 0, which means that we'll be able to retain the original value of the expression. And so now, given this, we now know that y is equal to, applying perfect square trinomial out here, so that is, take the square root of this one, and then copy this one. So we'll have x minus 1, and then squared. So we'll have x minus 1 squared out here. And then for this next one, negative 8 minus 1 is just simply negative 9. And so now, observe that this out here is already in its vertex form. If it's not evident, take note that you can write this one as y equals x minus 1 squared plus negative 9, which matches the vertex form. The vertex form. So recall that the vertex form is given by y equals a times x minus h plus k, something like this. So clearly this one matches the vertex form. Obviously, the vertex is given by 1 and negative 9 out here. And so that is the answer for our first example. So I hope you got that one correctly. And now let's move on to the next example. In here, we are given x equals negative y squared minus 4y plus 1. Again, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. So again, we focus on the term with the variable which has a square in it. In this case, it would be y. So we focus on this one as well as this one since it contains y. So we'll have this one. And let's apply completing the square out here. So we'll have x equals the group of negative y squared minus 4y plus a blank space out here plus 1. Take note that we put this since we want to apply completing the square. Now before we apply completing the square, take note that in completing the square method, we prefer the coefficient of the squared term to be positive 1. Positive 1 to be exact. Since this one is negative, we start by factoring the negative sign out. So we'll have x equals negative times y squared plus 4y plus a blank out. Take note that even though we factored out negative, this out here remained the same since this is just an unknown constant. So we can keep plus sign out here. And so we'll have this one. Now let's apply completing the square. So focusing on the middle term. So we'll have 4y out here. We divide this by 2 times the square root of the first term, or the square root of y squared, which is y. So dividing these 2, we'll get 2. Take its square and we'll have 4 out here. Now take note that you might be tempted to subtract 4 out here since we added 4 out here, but take note that we have a negative sign out here. So technically what we did in this expression is we subtracted 4. This means that to keep or preserve the value of the original expression, since we subtracted 4, in reality, we must add 4 out here. And so now we know that x is equal to, applying perfect square trinomial out here. So we take the square root out here, and we copy this sign. So we'll have y plus 2 squared. And don't forget the negative out here. So we'll have this. And then simplifying, 1 plus 4 is simply plus 5. And this out here is already in its vertex form. Clearly, this one is of the form y equals a times x minus h plus k. And given this, we know that its vertex, this vertex is given by, so we can write this as y minus negative 2. So we have negative 2 and 5. So that is the answer for this second example. I hope you got that one correctly. And let's now move on to the last example. In here, we are given y equals 3x squared plus 70. Again, before we start, feel free to pause the video so that you may try this one first on your own. Okay, so let's start. So take note that in here, you might be tempted to immediately apply completing the square, but take note that x out here can actually be expressed as x minus 0 squared. And so we can write this equation into y equals 3 times x minus 0 squared plus 17. Observe that this one is already in its vertex form since it matches a out here, x minus h out here, and k. So clearly, this one is already in its vertex form. And indeed, as a remark, take note that when the variable of degree 2 is alone, in this case, that is x. So when we say degree 2 is alone, what we mean by that is degree 1 of the same variable is not present. Or that is, in this case, since our variable of degree 2 is x squared, observe that the variable x, or some with coefficient, say ax, is not present out here. So if that is the case, then the general form is the same as the vertex form. As you can see, this one is actually just the same as this. No steps is needed to convert it. And just to end this, take note that the vertex out here is given by x out here would be 0, then 17. And so that's it for this example. And to formally end this, here's an exercise that you can work on. So in here, we're given x equals 2y squared minus 12y plus 7. Again, your goal is to convert this into its vertex form. Sorry about that. So your goal is to convert this into its vertex form, as well as find its vertex. And as a hint, the strategy to use here is quite similar to the second example, wherein you'll still need to factor 2 out here. Since our goal is, or what we want is that the coefficient of the squared variable is 1, positive 1 to be exact. So that's it. I hope you enjoyed and learned a lot from this one. Feel free to comment down below if you have an answer to this exercise, as well as if you have any suggestions and recommendations for this video and this playlist and this channel in general. So yeah, that's it, and that's all for this video.